Hi, my name is Jent. I'm an engineering design student at IIT Madras, and this is my video for the YC Summer Fellowship Grant. So, to start off, I'm an engineering design student in my fourth year, a dual degree, which is a BTech plus MTech program. I'm currently the one of the team leads of Team Agnirath, which is the institute's solar racing team. We build high efficiency solar powered vehicles to travel across large distances. Like in Australia, we compete in a competition which travels 3,000 kilometers. So we had to build a very efficient solar powered vehicle. This is me in the front when we had gone to the competition in 2023. I personally have built most of the electronics and software systems for the car, including the strategy, including the main control stuff. Like I have series of packages here, the battery related coding for the BMS, the steering systems, the driver interfaces, and I also built strategy models which would predict that would tell the driver to go at a certain speed at a certain point in time depending on the energy available, the solar input, the elevations, and the distance covered. Which like and so I had to model physical systems like the battery, the solar profiles, and how this would function in the and like it's almost a one-to-one replica of the physical systems of a solar powered vehicle. Apart from this, I have a patented invention, which is a hybrid fluid actuation mechanism, and which would use elastomeric actuators to ensure flexibility and high power output. So this was we had just gotten the design patent for it last year, and we had this is me and my team. We had gotten it from the official government of India, and we have also applied for another patent, which is the like utility patent for the design patent, which would be used as a physiotherapy device, which would use like the soft actuations and high power to be able to do a range of motions and would help in this kind of an aspect. So this is patent pending and should come in a few months. I also had built something I called Sentient AI, which is kind of like a very context aware chatbot that would have very low latency and would be able to understand more than just the speech, and it would like pick up things from like the facial expressions, tone of voice, and that would do like and understand all that and give a bit more of a contextually aware response. This was just like a small project that I had been doing. Apart from that, now what I plan to do for the actual project during the summer would be something I have been working on, a startup called Ingenuity AI. This was kind of like a front end for engineering tools, and here's the video for that. Let us ask ourselves a fundamental question. What is engineering design? I'd like to call it the iterative process of developing innovative solutions through methods of design, simulation, and prototyping. The average engineer spends most of his time using complex engineering software to design 3D models, electronic circuits, and run simulations in the process of prototyping his product. I say we can do better. Introducing Ingenuity AI, we want to empower engineers to focus on the creativity of problem solving rather than the limitations of software tools. Our solution? An all in one design studio to create your products. Our studio enables a user to interact with our collection of AI agents to augment their engineering workflow. These agents act as an intelligence layer on top of your favorite software tools to turbocharge your productivity. Introducing Archimedes, our first AI agent designed for CAD and 3D modeling. Archimedes harnesses the power of large language models to interact with any CAD software to perform actions related to 3D modeling. Archimedes can generate, edit, and iterate over designs with simple natural language instructions. Say you want to design a NACA airfoil on Fusion 360. Archimedes has you covered. So open the design studio, type in your requirement, and wait for the large language model to generate a parameter model. And once that's done, you select your parameters like shown here. For the airfoil, we'll select a few parameters. Now confirming the parameters, giving it a few seconds to generate the 3D model on the software, we should be able to see a NACA airfoil. This is just the beginning. We have planned to launch 2 more agents in the coming year, Tesla and DaVinci, targeting PCB designing and simulations respectively. These agents would be able to interact with one another to share files and information. Take the airfoil we just designed. Say we wanted to determine the drag coefficient. Archimedes would send the 3D model to DaVinci to set up a fluid simulation on ANSYS and determine the drag coefficient. If the value was unsatisfactory to the user, DaVinci would send it back to Archimedes to redesign and send back to simulation. Like mentioned before, our design studio is cross-platform compatible, tool agnostic, and would adapt to any user or enterprise's existing software stack. Let us harness the power of AI to usher in a new age of engineering.